Hello everyone, and welcome back to COMM 215 Business Statistics. Today we're going to go over Lesson 5, Continuous Probability Distribution. So without further ado, let's get started. An institution estimates its weekly meetings to last 30 minutes on average. The standard deviation of the meeting's duration is 4.3 minutes. Assuming that the duration of the meetings is normally distributed, question A is asking us to find the z-score of a meeting that lasts, and then we have 3 sub-questions. So, before we get deep into the problem, there's one thing that I want you to get into the habit of doing from this point forward. What we're going to do right now is we're going to go ahead and draw our bell-shaped distribution, so our bell-shaped curve, and that's going to help us better position our cues, and then we'll be able to solve the problem with a lot more ease. So, let's go ahead and do that. Okay, so there is my bell-shaped curve. Okay, so now that I have my bell-shaped curve, there's a few things that we can point out right away in the question. Okay, so the first thing we know is that the institution is estimating that the weekly meetings last 30 minutes on average. Okay, so let's go ahead and draw that in our bell-shaped curve. Okay, so we know that the mean is 30 minutes. Okay, we can even go ahead and put the minutes in. It's not a problem. Okay, so the meetings last 30 minutes on average. What else do we know from the question? From the question, we can also see that the standard deviation is 4.3 minutes. Okay, so let's go ahead and write that down as well. Okay, so we have a standard deviation that is equal to 4.3 minutes. Okay, and there's one more piece of the puzzle that is very, very important that we cannot omit, and that is that the duration of the meetings is normally distributed. Okay, now this is very important. Why is this so important? Because this is going to allow us to use this bell-shaped curve. Okay, when something is normally distributed, it means that on either side of the curve, we have the same space, the same area, so the same probability. Okay, because the curve is symmetrical or is normally distributed, we will have on either side a probability of 0.5 and 0.5 for a total of 1. Okay, so they have to add up to 1 because we know that our probabilities always add up to maximum 1. Okay, so now that we have this portion of the problem set up, it's going to be a lot easier to go in and determine the z-scores because we're going to be able to visually see where our x's are going to fall within the bell-shaped curve. Okay, so let's go ahead and do that. Okay, so question A says find the z-score of a meeting that lasts, and the sub-question A says 25 minutes. Okay, so we know that 25 minutes falls on the left-hand side. Okay, now that's going to be important for a reason you'll see in just a minute. Okay, so we know that an x of 25 minutes, okay, so a meeting that lasts 25 minutes falls on the left-hand side, and now I want to determine its z-score. Okay, so if I solve from my formula, z equals x minus mu divided by the standard deviation. We know that we have everything we need. So we have our mean right here, our standard deviation up here, and we have our x right here. So all we have to do is solve. Okay, so let's go ahead and plug everything in. So this is going to give us 25 minus 30 divided by 4.3. Okay. And this is going to equal, so just take a second to compute it in your calculator. This is going to give us a z-score of negative 1.1628. Okay. So there's a few more decimals than that in your calculator, but here's the important thing to note. When you look at the Z table in your books, the Z scores are always rounded to 2 decimals only. So, aside from getting into the habit of drawing the bell-shaped curve, let's also get into the habit of rounding our Z scores to 2 decimals, okay? So in this case, negative 1.1628, because the third decimal that follows the 6 is a 2, we know that we're going to round down, so meaning in this case that we're going to keep our 6. So this is going to equal 1.16. Whereas if, let's say for example, okay, and this is just a hypothetical example, it has nothing to do with the question, let's say that our z-score had been negative 1.1658, okay? Anything that is 5 and above in the third decimal, that means we round up, and so our z-score would have been negative 1.17. Now, it may not seem like much, but in the Z table, this will make a difference, okay? Every Z score is determined every 2 decimals. So, for example, you'll have negative 1.16 is one Z score, negative 1.17 is a different Z score, okay? So it will make a difference. So make sure that you get into the habit of rounding your Z scores to 2 decimals and that you round up the proper way. So up if the third decimal is 5 and above, and down if the third decimal is 4 and below. Okay? Wonderful. So this was the answer for sub A. So I'll put little a here. Okay, so that's little a, negative 1.16. And also very, very important, I can't stress this enough, please don't forget the negative sign, okay? It's very, very important. It won't make a difference for the Z score per se, in the sense that in the Z table, whether you take negative 1.16 or 1.16, it will give you the same probability within the table. That, I agree. But when you're determining here the probability within your bell-shaped curve, whether it's negative or positive, it will have an impact on your final answer. Okay, so very important not to forget the negative, which means that it falls on the left-hand side of the mean. Okay, so let's go ahead and do question B. So sub B is asking us to find the z-score of a meeting that lasts 29 minutes. Okay, so I'm going to draw it up here. I'm going to erase this here. Okay, so let's go ahead and draw for question sub B. So we want to find the z-score of a meeting that lasts 29 minutes. Okay, so we're going to draw it again. Okay, so for a meeting, so X, so any given meeting that lasts 29 minutes. Okay, so we're going to repeat the same process to find our z-score. So our z is equal to x minus mu divided by the standard deviation. So that's going to be 29 minus 30 divided by 4.3. So notice that our mean and our standard deviation haven't changed. Okay, we're still solving for the same overall problem. It's just the sub-questions are different, so the x's are different. Okay, so this is going to give us a total of negative 0. 0.2326, which, let's get into the habit of rounding to 2 decimals, don't forget that. So it's going to be negative 0.23, because the third decimal is below 4, so we round down, so we keep it at 3, okay? So very important, once again, don't forget the negative. Okay, it's very important, don't forget it. And finally, let's go ahead and do C. Okay. So C is asking for to find the z-score of a meeting that lasts 39 minutes. So now we're going to be on the right-hand side. So let's put it over here. So for any given meeting, that lasts 39 minutes. Okay. So let's repeat the process one more time. Let's find our z-score. So z is equal to x minus mu divided by the standard deviation, which in this case will be our x, which is the difference. So it's the different part of question C. So 39 minus 30. So our mean hasn't changed. That's what I mean by that. Divided by our standard deviation, which hasn't changed, 4.3. And this is going to give us a total of 2.0930, which we all know now to round to 2 decimals, so that's 2.09. Okay, so notice how here, okay, because our x is on the right hand side of the mean, our z-score is positive. Okay, so remember earlier when I said that the negative z-score makes a difference? That's because it's for values that were on the left hand side of the mean. So all the x's that are smaller than 30, anything below the mean will give you a negative z-score. Anything above the mean will give you a positive z-score. And that's going to be very important for when we're going to solve the second question coming up. Okay, so keep that in mind. I'll write it down here. So anything above the mean will give you a positive z-score. And let's take a different color. Anything below the mean will give you a negative z-score. Now, the reason why the z-score is negative, let's look at our z-score formula. We know that in the numerator, we have x minus mu. So if we think about it, any x's that fall below the mean will equal a negative numerator, which divided by the standard deviation will give us a negative z-score. Now, as you know, the standard deviation can never be negative because it comes from the square root of the variance, and the variance has to be positive because if not, we cannot square root to obtain the variance, right? And the variance is always positive because we always do x minus x bar to the power of 2. Remember that to cancel out the errors in the variance formula and the standard deviation formula. So that is why we will never obtain a negative variance and thus never a negative standard deviation, which is impossible, okay? So on the right-hand side, to finish up, the reason why we obtain positive z-scores is because in the numerator, if we look at problem C, our x will be greater than the mean, which corresponds to what we were saying earlier. So any x's greater than the mean will give us positive z-scores because our numerator will be positive, divided by a positive standard deviation, right? Okay, so very important. So let's do one final recap. The reason why we can do all these problems using the bell-shaped curve, so this bell-shaped curve, this symmetrical curve, this normal distribution, is because in the problem it's clearly stated that the duration of the meetings is normally distributed, okay? So that is why we're allowed to use this curve, which on either side has a probability of 0.5, and 0.5, which represents the area under the curve. Okay, so it's symmetrical. And once again, we know that the meetings last on average 30 minutes. Okay, so that is our mu. And we know that the standard deviation is 4.3 minutes. Okay, so that is right up here. Okay, so very simple. Besides these three concepts, the normal distribution, standard deviation, and the mean, the only other thing is we apply our z-score formula, which is available in your formula sheets. Okay, so let's move on to the second part of the question. Okay, so the second part of the question takes the same problem that we had in the first part, but is asking us to find something different. In this case, in part B, we want to find the probability, no longer the z-score, that a meeting lasts, and then we have the three subsections, okay? So let's go ahead and redraw our bell-shaped distribution. This will be a nice little recap of what we just did before. Okay, so I'm gonna draw my bell-shaped curve once again. And I know it may seem tedious at first, but it's really important to get into the habit of doing this, particularly when we're finding probabilities like we're about to do, and you're going to see why in just a moment. So we know that our mean is 30 minutes, okay? And we know that our standard deviation, okay, so I always like to write these down just so I have them as a quick visual cue right here for when I'm solving my problem. So extract them from your problem. It's a lot simpler. And then from here, because we know it's normally distributed, so it's symmetrical, it's a bell-shaped curve that is perfectly symmetrical, we can go ahead and solve very easily for question B. So question B is asking for, in subsection A, the probability that a meeting lasts less than 26 minutes. Okay. Now before we do that, I just want to point out one thing. Like I said earlier, we're no longer finding z-scores. Now we're finding probabilities. And probabilities in the bell-shaped curve represent, as I mentioned earlier, areas under the curve. Okay? So what I mean by that is the following. If they want to know the probability that a meeting lasts less than 26 minutes, so our meeting here is going to last 26 minutes, but I want the probability that it'll be less than 26 minutes. So in effect, this right here is what I'm looking for, right? Now the reason why probabilities are areas under the curve, a second reason I should say, is because the probability at a given point, so if I was just to say, what is the probability that the meeting lasts exactly 26 minutes? At that given point exactly, the probability is 0, okay? Because what you're going to be doing is 26 right here at this specific point. There is no variation. You just want to know the exact probability at 26 minutes. And because there's no variation, it's at that one specific point. So the probability is 0 for a specific point on the bell-shaped curve. We're almost never going to be solving for a specific point on the curve. We always want an area under the curve, and that's going to represent a numerical probability, okay? So an actual number, I should say. So because we want this area right here, how we're going to solve for it, we're going to first find the z-score, which we did in part A, and then once we have our z-scores, we're going to look into our z-table, okay? So let's go ahead and do that first. So step 1, let's determine our z-score. So we're already used to doing these. We did 3 of these in part 1. So it's x minus the mean divided by the standard deviation. So it's going to equal 26 minus 30 divided by 4.3. And this is going to give me a z-score of negative 0.93. Now notice how I already rounded to 2 decimals, as I told you guys to get into the habit of doing that. So the actual number, I believe, is 9302 and quite a few other decimals. So I took the liberty of rounding it to 2 decimals already, okay? So now, one thing I like to do once I have my z-score, I like to go ahead and place it as a visual cue on my bell-shaped curve, okay? And then I'll be able to show you something pretty cool about the bell-shaped distribution. So one layer of the bell-shaped distribution is when we use the means and the x's. Another layer is when we're going to use the z-scores. Now what I mean by that is the following. An x of 26 minutes is represented by a z-score of negative 0.93. Okay? And the mean in the z-score layer is represented by a z-score of 0. Why? Think about it. If I want to find the z-score at 30 minutes, that's 30 minus 30, which is 0, divided by 4.3. It's 0. Okay? So this here is the mean layer, where we have the mean and the x's, all represented in minutes. And this here is my z-score layer. But notice how they mean the exact same thing. Why? Because the z-score will give you the deviation from the mean, right? This z-score tells me that we are 0.93 away from the mean. And the x, 26, tells me that I am 4 minutes away from the mean, okay? So this is a deviation of 0.93, and it's negative, so it's on the left-hand side, okay? So they both mean the same thing right here, just represented differently. And the reason why we do this is because we need the z-scores to go look into our z-table to find the probabilities. We cannot do that with the layer of the x's and the means. We need the z's, the z-scores, in order to be able to look at the probabilities in the table. So let's go ahead and pull up a table and see what our probability is going to be. All right, so here is a Z table. Now, don't worry if we don't cover everything for the Z table here. Make sure to check out the video for how to use the Z table, which should be available already. Alrighty, so we know that Z scores are represented on the outskirts of the table. So on the margins, horizontally and vertically, these are my Z scores. And within the table, what do I find? I find the probabilities, okay? So I know that my z-score is negative 0.93. Now, if you remember earlier in the video, I mentioned that for using the table, the negative sign doesn't matter. The table is an absolute value, so it disregards the negative sign. So we're simply going to look for 0.93, and we're going to plot that probability on the left-hand side. But that's why the negative is important. Okay. So let's go ahead and find the probability for a z-score of 0.93. Okay. So in the table vertically, we're going to have the first portion of the z-score, which is our 0.9. And horizontally, we're going to have the third decimal, which in this case is 3. So right up here, 0.03, and we're going to look for the intersection between the two. So between 0.9 and 0.03, which gives us our 0.93, we have a probability of, so I'm going to write it like this. This is just the mathematical way of writing it. So the probability of a z-score equals 0.93 is equal to 0.3238. Okay, so little recap. I found the intersection between 0.9 and 0.03, which represents my z-score of 0.93, and that's a probability of 0.3238. Okay, so let's just get rid of the table real quick. Now that I have this probability, I need to know where to place it. And this is where the negative portion of the z-score comes into play. When putting probabilities inside the bell-shaped distribution, it's always done, I can't stress that enough, always done in relationship to the mean. What I mean by that is, we know that the probability for z equals 0.93 is equal to 0.3238, right? But we know that it's negative 0.93. So remember when I told you earlier, negative means that it falls on the left-hand side of the mean. So 0.3238 is going to fall right here on the left-hand side of the mean. Okay, so that's what I meant by in relationship to the mean. That means that you start at this little bar right here, and then if it's negative, you go right to the left, and if it's positive, you go straight to the right. Okay, so because we have a negative z-score, our probability starting from the mean is going to fall right here in this little slot on the left-hand side. Okay, but we're not done yet. Okay, very important. It'd be a shame to lose points if you stop right here. Okay, what we wanted from the beginning was a probability that a meeting lasts less than 26 minutes. So we even highlighted the area. It's this piece right here of the tail that we want. So what do we have to do? We know that because our bell-shaped curve is normally distributed, that the area under each side represents a full 0.5, right? So that's the same on either side because it's symmetrical. Okay, so this here is also 0.5. So if I want this little tail right here, what do I have to do to 0.3238 to obtain this little tail right here? You would agree with me that I have to subtract 0.3238 to obtain this little tail right here, right? So we know that, I'll draw it here, I think it'll be more evident. Okay, we know that this right here, let's just get rid of that. So we know that the area under the curve, because it is symmetrical, the full area is 0.5. So to obtain my tail, I take 0.5 minus this little piece right here, which goes from my mean to my x, or my z-score. So this little box right here, I subtract it from 0.5, and I obtain my little tail right here. Okay, so let's go ahead and do that. So I'm going to write out, rather, the mathematical form of this, and you'll see that it's much easier. So this was my step 2. I apologize, I did not write that down. So finding the probability was my step 2. So step 2 is to look inside the Z table for our probabilities, okay? Okay, and finally in step 3, we're simply going to determine the probability of what the question is asking us for. So we want the probability that our Z-score be less than negative 0.93, which is the same thing as what the question is asking us for, which is the probability that my x be less than 26 minutes. Okay? Now, whether you would write less than or equal to, same here for the z, it doesn't really matter because of what I explained earlier, that at a point on the bell-shaped curve, the probability is 0. Okay, so we often write just less than 26, or here less than 0.93. Okay, so these two are the same thing because of what I said earlier, remember. So here we have the layer where we express things as the mean, and the x's, which are in minutes. Okay, so these are in minutes. And then we have the layer below where it's the exact same things, but that are expressed in z-scores. Okay, so 26 minutes is 4 minutes away from the mean, which represents a z-score of 0.93. So that's 0.93 away from the 0, okay, which is the middle of your bell-shaped distribution. So that's why we can write this out like this. Both mean the same thing. And to solve for this, it's simply equal to 0.5, which is the total half. Okay, so the left-hand side half, well, left or right, in this case, the left-hand side half. It's 0.5 minus what we found right here, because the probabilities that we find in step 2 are plotted in relationship to the mean. Okay, so we start from the center and then we go left or right. So minus 0.3238, and this is equal to our tail right here, which is the remainder, and that is a total of 0.1762. So 0.1762. Okay, so there is our answer. Now, it may seem like a lot, but we have 2 more to go, so we'll be able to recap all the different notions. All right, so let's go ahead and do subsection B. So subsection B is asking us to find the probability that a meeting lasts between 27.85 minutes and 34.3 minutes, okay? So let's go ahead and plot the visual cues on our bell-shaped curve before we solve anything. It'll make it a lot easier to see what exactly it is that we're looking for. So we're looking for a meeting that lasts between 27.85 minutes and 34.3 minutes. Okay? So you see how much easier it is once I've plotted my visual cues. I know now that because I'm looking for what's between these two times, that I'm looking for a meeting that is anywhere in here. Okay, so this is what I want to find. Okay, so the visual aid really does help. Okay, so let's just go ahead and divide this once again. So this is the layer of our mean and our x's, which is expressed in minutes. And now we're going to go ahead and find step 1, which is our z-score, okay, in order to be able to find our probability. All right, so let's go ahead and do that. So step 1, let's find our z-score. And here, because there are 2 times, so we have the 34.3 and the 27.85 minutes, we're obviously going to need to find 2 z-scores, okay? So let's go ahead and do the first one. So that's going to be, as always, x minus mu divided by our standard deviation. So the first one is going to be, we'll start with the one here on the left. So it's 27.85 minus 30 divided by 4.3, and this is equal to negative, so please don't forget the negative. It's going to be important for later. So negative 0.5. So let's go ahead and find our second one before we put them in as visual cues. Okay. So the second one, I'm not going to write the generic formula. I'm just going to go ahead and write my numbers since the generic formula is right above. So it's going to be 34.3 minus 30. So notice how it's going to give me a positive numerator divided by my standard deviation, 4.3, which hasn't changed. And this is going to give me a z-score of 1. Okay, so let's go ahead and plot our visual cues. All right, so on the left-hand side, we're going to have a z-score of negative 0.5 right here. And on the right-hand side, we're going to have a z-score of 1 right here, okay? All right, so now the next step, now that you see, I'll do a little something so everyone can see what I meant earlier. So this is what I meant. These two represent the same thing, and these two represent the same thing, just in different forms. So an x of 34.3 minutes is 4.3 minutes away from the mean on the right-hand side, which represents a z-score of 1. So you're 1 away from the center of 0. Okay, so that's positive 1, so it's on the right-hand side. Whereas a meeting that lasts 27.85 minutes is on the left-hand side, so it's less than 30, which represents you're 2.15 minutes away from the mean, from the center. And it's a z-score of negative 0.5, so you're 0.5 away from the 0, the center, on the left-hand side. Okay, and this will now allow us to find the areas under the curve, so our probabilities. Okay, so let's go ahead and do that. So let's pull up our z table and once again find our probabilities. So the first z-score that we're looking for, we'll do the one on the negative side. So the left-hand side, we have 0.5. So here it would be right here at 0.5. And there's no third decimal, so that would be our 0 right here. So that is a z-score of 0.1915. Okay, so let's go ahead and write that down here. Okay, so a probability of our z-score being equal to 0.5 is a probability of 0.1915. Okay, so now let's do the second one. Let's take a different color. Let's go with some red. So let's do the one on the right-hand side, which was equal to a z-score of 1. So that would be right here at 1. There's no third decimal, so we would once again have the 0 as the third decimal, and the intersection is 0.3413. So let me go ahead and write that. Okay, so the probability of z equal 1 is equal to 0.3413. And now we can go back to our, so it's equal to 0.3413. Now we can go back to our bell-shaped distribution and plot our visual cues. Okay, so let's just go ahead and get rid of our table. Okay, so we know that the probability, so I'll rewrite them, the probability of z-score equals 0.5 is equal to 0.1915, and the probability of our z-score equals 1 is equal to 0.3413. Okay, so this is our step 2, was finding our probabilities. And now in our step 3, we're going to solve for the area that we're looking for. And in this case, very important, okay, so this is a little bit different. I'm looking for the area between these two numbers, so between 27.85 and between 34.3. So we know that because our probabilities are in relationship to the mean right here, the 0.1915 is going to fall right in here, 0.1915. Okay, so it's for our negative z-score, so it's on the left-hand side, or our smaller x than the mean, so on the left-hand side. So in relationship to the mean, on the left-hand side of this bar is going to fall this probability, which represents the z-score of 0.5, which is right here. So it equals this right here is 0.1915. Okay. All right, so that's my 0.1915. And now on the right-hand side, for a z-score of 1, or an x of 34.3, in relationship to the mean, to this bar right here, my 0.3413 is going to go on this side right here. Okay, so that's 0.3413, okay, which represents this right here. Okay, so in relationship to the mean, it's this right here on the right hand side. And now because I'm not looking for the tails, I don't have to do 0.5, so the full half minus anything. I just have to add the 0.3413 and the 0.1915. Okay, so let's go ahead and solve for the full area under the curve, which is the between that we're looking for. So I'm going to write out the mathematical interpretation of subquestion B, so you see what that sentence form equates to in case the problems in your exams are given in this form. So this simply means that we want to find the probability, so my P, of an x that is greater than 27.85 and smaller than 34.3. And as you know, so this is for the x layer, so the layer that is expressed in minutes, which also contains the mean. We can also write this out for the z-score layer, which would be a probability that our z-score is greater than negative, don't forget that, 0.5, and less than 1. And less than 1. Okay? And this is equal to, in both cases, okay, it's just different layers that mean the same thing. It's equal to 0.1915 plus 0.3413. So my two areas under the curve, my two probabilities. And that is a total of 0.5328. So remember, the negative is important because that's why it's on the left-hand side, the positive right-hand side, and in this case, we don't want tails at the extremities, so we don't have to do 0.5, which is the full half, minus anything like this. We want the in-between, so we're simply going to add the left and the right up, and that gives us 0.5328. So the probability that a meeting lasts between 27.85 and 34.3 minutes is 0.5328, or 53.28%. Okay, so let's move on to subquestion C. So let's finish off with our last subquestion C. They want us to find the probability that a meeting lasts between 31 and 37.6 minutes. So let's go ahead and plot our visual cues before we do anything else. So we want a meeting that lasts between 31 and 37.6 minutes. So we're looking for the area under this particular section of the curve. Okay? So this is the layer of our mean and x's expressed in minutes. So now we're looking for, which is what we're about to solve for, our z-scores. Okay, so let's go ahead and solve for those now that we have our visual cues lined up. So once again, same as in subsection B, we're going to need two z-scores here. So in step 1, we're going to solve for z-scores. So the first one, so it's always, for this lesson, it's x minus mu divided by the standard deviation, which is equal to 31 minus 30. Notice that it's going to give a positive numerator, divided by 4.3. And this is positive because 31 is greater than 30. So it's going to be on the right-hand side. And this is equal to a z-score of 0.23. Okay, so once again, I took the liberty of rounding to 2 decimals because in the z table there are 2 decimals. Okay. So let's go ahead and do the second one. So that is 37.6 minus 30 divided by 4.3. So this is going to equal 1.77. So once again, I rounded to 2 decimals. And now let's pull up our z table and determine what the probabilities assigned to those z-scores are. Okay, so let's go ahead and do the first one. We're looking for the probability of z equal 0.23. So that is the intersection between point 2 right here and our second decimal are 0.03. And that is a probability of 0.0910. Okay, so that's our first one. Our second one is the probability of z equal to 1.77. Okay, so that is the intersection between 1.7 and our second decimal over here at 0.07, and that is right here at 0.4616. Okay, so now that we have our probabilities, let's plot them as visual cues inside our bell-shaped distribution and go from there. So in step 2, as we just found, let's do a small little recap. So the first one, 0.23, we know is equal to 0.0910. And the second one, the probability of z equal to 1.77 is equal to 0.4616. Okay, so let's go ahead and plot the probabilities inside the bell-shaped curve. Alright, so now pay attention because this subsection C is a little bit more particular in terms of how to find the probability. Okay, it's just a little tricky. So that's why we're going to draw them. So let's go ahead and do that. so I can show you what it is that's different about this question. So as we know, the probabilities are always plotted in relationship to this right here, which is our center, our mean. So from this bar, okay, just for sake of example, we know that we are on the right-hand side, so our probabilities are always going to be on the right-hand side of our center right here, of this bar of our mean. So the first one, for x equals 31, is at a z-score of 0.23, and that is 0.0910, the probability. So that's going to go right here, and that's going to be 0.0910, and that represents this right here. Okay? Now our second one is at x equals 37.6. So for a z, now this one I'm going to do in a different color just so you see what I mean, of 1.77. And so once again, we're on the right-hand side, starting from our center. That's going to be all the way up to this x right here. So all this right here is going to represent this probability of 0.4616. Okay. Now, I'm just plotting the distance horizontally, but you understand that the 0.4616 is all of this right here. Okay. It's this right here. Same as, I'll take the orange again, the 0.0910 is this area right here. Okay? But we know that what we're trying to find is just this piece right here. So what do we have to do to 0.4616 to obtain just this piece? Simple. We're just going to subtract this little area piece right here, so 0.0910. So you see why it's important to plot it in your bell-shaped distribution, because the visual really helps to determine what exactly it is that you're looking for and what you have to subtract or add together in order to obtain your final answer. So let's go ahead and do that. Okay, so in our step 3, so I'm going to, so in our step 3, so I'm just going to write out the mathematical interpretation. So this is that our x is greater than 31 minutes and smaller than 37.6, which is the same thing. So let's write it as the z-score layer, which is the same thing as the probability of having a z-score that is greater than 0.23 and smaller than 1.77, and this is going to equal, so we're just going to take the larger piece, the 4616 probability, and subtract the smaller wedge, (0.910), and it's going to give us our final answer, which is 0.3706. And there you have it. Okay, so once again, very important to plot all your visual cues from the question on a bell-shaped distribution, and the reason why we use a bell-shaped curve, a normal distribution, is because it's very clearly stated in the question that it is normally distributed, so each half is equal to 0.5, and then as we go along, we're plotting out the layer of our x's or our mean, which is in minutes in this case, and then the layer of our z-scores. Okay, so for this x of 31 represents a z-score of 0.23 with a mean of 30 minutes and a standard deviation of 4.3 minutes. And then with this z-score, we can then find the probability. So this area that it represents, so up to this bar. Okay, so I'll do this right here. So up to this point right here, so up to this wall, this piece right here is represented by So this area is represented by this probability. And then with the probabilities, we can answer our questions depending on what it is exactly that they're trying to find out. So I hope you enjoyed that. Thank you once again, and good luck studying.